All right, here's our second video from section 6.3. We just got done talking about adding rational expressions that have common denominators. Now let's talk about what happens when we're subtracting rational expressions that have common denominators. As long as they have a common denominator, you should be able to subtract your two fractions by, remember, keeping your common denominator, but making sure that you subtract every term in the numerator. That means you have to make sure that you distribute the negative through. Let me show you an example. If I ask you to subtract these two rational expressions, it looks like they already have a common denominator of x plus 2, so I can keep that common denominator. But then when I go to subtract my numerators, I have a 3x and I want to subtract an x and I want to subtract a negative 5. And hopefully we know that those two negatives really make a positive. So what we really need to do is distribute that negative through. So again, I have my common denominator of an x plus 2, and then on my numerator, I really have a 3x minus x plus 5, making sure that I distribute the negative to every single term in that second numerator. That's the most common mistake students make, so be careful. Now I can combine like terms. I have a 3x minus a 1x, which is really a 2x plus 5 on the top, and an x plus 2 on the bottom. I don't notice anything that can be factored, and I notice that I have 2x plus 5 in the numerator and x plus 2 in the denominator. Nothing really can be reduced, so it looks like that would be my final answer. Let's try B. I'm subtracting fractions. I've got a common denominator, so that's good. I can go ahead and keep that common denominator. But then I'm going to go ahead and subtract my numerator, making sure that I distribute this negative through to both terms in my second fraction. That leaves me with an x squared minus x minus 12. Now don't stop if you can reduce it more. You notice that this numerator looks like a basic factor problem. It's a trinomial. Let's see if we can factor it and reduce it any more. What numbers multiply to negative 12 that add to give you negative 1? Yeah, I got negative 4 and positive 3. And so then look what happens. Don't the x minus 4 factors from the top and the bottom reduce? And then so what do we have left? Yeah, our final answer is just x plus 3. Or you could say x plus 3 over 1 if you wanted to. But x plus 3 would be our simplified final answer. Making sure you distribute the negative and then factor to see if you can reduce more. Why don't you try 2 before you move on? Actually, it looks like there's 3 of them here. Why don't you try a couple of these before you move on? So here's 3 problems. Pause the video, add, subtract, and it looks like number 3 has a combination of the 2. So follow the steps, keep your common denominator, and then add or subtract your numerators. And let's see how you do. All right, number 1 asks us to add. We can add fractions as long as we have a common denominator, which we do. We're going to keep our common denominator and then just add our numerators. So we have a 3x plus 4 plus 2x minus 9. I can combine my like terms and really say that I have a 5x minus 5 over x minus 1. If you can reduce, though, we need to reduce. I notice in my numerator that I can take out a GCF of a 5. That leaves me with an x minus 1. And if you notice now, there's an x minus 1 factor on the top and the bottom that I can reduce, leaving me with a final answer of just 5, or 5 over 1. Hopefully you got the same thing. All right, let's do a subtraction one. Subtracting fractions is the same idea. We can subtract fractions as long as we have a common denominator, which we do. And then we can just subtract the numerators, but make sure you distribute that negative to both terms in that second fraction. So on the numerator, you should have an x minus 4x plus 3. That's really huge. All right, combining like terms, it looks like I have a negative 3x plus 3 in my numerator and an x squared minus 1. But let's see if we can factor any more to help us reduce. It looks like my numerator has a GCF that I can actually factor out a negative 3, leaving me with an x minus 1. My denominator is a difference of squares. I can factor that into an x minus 1 and an x plus 1. I see a GCF of an x minus 1 on the top and the bottom. That leaves me with a negative 3 in my numerator and an x plus 1 in my denominator. All right, now that we've done a single addition and a single subtraction, what if I stepped it up a little bit and did one of each in the same problem? Hopefully your last fraction, I made a little typo there, hopefully your last fraction has a minus sign in between and that says an x minus 5. You notice though, I'm subtracting and adding fractions, so I need to make sure that I have a common denominator, which I do, so perfect. I can keep that common denominator. Don't mess with it. Keep it there. Now, we're going to take the 6x, but we're going to subtract 4x and subtract a 7, but we're going to add an x and a minus 5. So your numerator should look like this. You have a 6x minus 4x minus 7, because I have to distribute the negative, plus x. Uh-oh, is that supposed to say minus 5? Minus 5. All right, so combining like terms, I have a 6 minus 4x plus 1x. That gives me a 3x. And I have a negative 7 and a negative 5. Hopefully if you changed it, sorry about that. A negative 7 and a negative 5 give me a negative 12 in my numerator. My denominator is still the x squared minus x minus 12. Now be careful. I almost want to reduce those 12s, but I can't. Remember, they're connected with a plus or minus sign. The only thing I can try to do is factor the numerator, factor the denominator, and see if there's any GCF in both. All right, it looks like the numerator can be factored with a GCF. I can take out a 3, leaving me with an x minus 4. The denominator is a basic factor, so I can factor that into an x minus 4 and an x plus 3. Ooh, they have a common factor, so I can reduce an x minus 4 from the top and the bottom. That leaves me with a 3 over x plus 3. Now be careful, don't reduce the 3's off. If you can't reduce a 3 from everything, then you can't reduce. Let's just go ahead and leave it like this. 3 over x plus 3 would be our final answer. All right, make sure that you are good to go with adding and subtracting rational expressions with common denominators, because eventually they're not always going to be common denominators, and we're going to have to add one more step on. We're going to have to get our own common denominators and then add and subtract. So make sure you get good at this before we get a little bit harder.